Can you see my screen?
Yes, I can.
Good. Is anybody there? I don't hear anybody.
I can hear you.
I'm here.
Okay.
We're muting.
We're here.
Okay.
Yeah, we're here.
Thank you all for coming and sharing the weekend with me. I'm planning to run a fun session, Annihilating Dots on a Circle, which James Stanton did in our math circle at ASU 2 weeks ago. I've never done this one before live, but I think it should be a real fun activity. Let me introduce you myself. Let's see, where is it? So I'm from near Hamburg in Germany, where, yeah, this picture, can you see this picture? Good. So this one is an area which is really, really cold and wet all the time, and very, very rarely do we see any blue sky like this one over here. And I always was dreaming of coming to some of the nicer places in the world. And let's see where they are. So my dream has been this one over here. When I was a child, I saw pictures of this one and I said, that's where I want to end up. And I was very patient. It took me many years, but at age 23, I finally became an exchange student in Colorado. And then my first travel over to Monument Valley, I was absolutely blown away. And so I decided to stay here, and I fell absolutely in love with the country here. Let's see. I forgot which one is which of these things. So I've been walking all over the place. So this one is my favorite area, and I would like to thank you all for letting me walk on your homelands, and I'm absolutely blown away. I have a few more in here. Sometimes we help you. Some of your DNA lands are falling apart. And so here we are holding up the rock so that it does not fall down. It was really, really heavy, but that is one of my favorite shots in the canyon. This one, I have 2 young daughters, which also love the lands out here. And right now, Monica will be working in the winter again and remove the bad fish, the introduced fish which don't belong into the Colorado River. And she said, we don't put any to waste. They go all to you in the Dene Nation for food. And but it is replacing all the bad stuff. Okay, I can't see many of you. Thank you, Mr. Preston. I can see you, and so on. It always helps me to have some cameras there. So what I would like to do with you is a session Annihilating Dots on a Circle. And this one is, oh, I have just one more thing in here. Yeah, I've been with the Navajo Math Circuits for, I think, 8 years. And if you have not watched the film, I urge you to do this one by all means. So 8 years ago, a professional film was made of one of the first sessions of the math summer camp. And the easiest way is just to Google Zala. Zala is the company which made it, with George Sirini, and Navajo, Zala, Navajo Math, and anything like that gives you a tribute of them. And I have some update for you. The young lady in there who is a very prominent person in the film, Charmaine, she just graduated from ASU with an engineering degree and now is in graduate school in a master's program in biomedical engineering. We just had lunch 2 weeks ago. And so watch her 8 years after she came to the first math circles, now having a career in biomedical engineering. And it's just absolutely awesome. So that's where I started. In the video, you're actually gonna see me in the first 3 minutes that I spent ever teaching at the high school level, the first 3 minutes ever being on teaching your students. And I was so scared at that time. And it is still in the film, and we had a real good connection in there with Charmaine and Evelinda. So make sure that you watch this film if you have not watched this one. So this one goes away.
The activity. Nakatyani was on one of the icons on the film. There is a student at Stanford University. We have a couple.
Say it louder.
Nakatyani is a student at Stanford University at the moment.
Oh wow, yeah, I know about him. Yeah, I haven't had contact with him, but it is something. Bring your kids to the math circles, and we hope that this is the beginning of a great career. So the activity which I have is stolen from James Tanton. He is an absolutely unbelievable guy. He's a Princeton mathematician, but he has taught in high schools, and right now he's traveling the world all over. And he's just really, really fun with his own Wikipedia page. And we are really lucky to have him at ASU for a few days a year, because he is traveling all the time. And the reason that he is at ASU is because his wife is the dean of our School of Space and Earth Exploration. And that is one where we are hoping to mix the math circles together with geology in the next year, when hopefully this pandemic is over and we have summer math and geology camp, hopefully together. So Exploding Dots is a slightly different activity which he has, but he is an Australian, and so his new website is Good Day Mathematics, Good Day Mathematics. So if you want to see anything fun in mathematics, this one is one of the best sites to actually get some activities, and I hope that my introduction today will work reasonably well, so that you get excited and say, I want to learn more from the guy who creates all this cool math. So let's start with this activity in here. And I, can you see this? So the story, I'm gonna keep it with the same storyline as James did it with our math circle, with our high school students, but I think it does not really fit what we'd like to do in the math circles, in the Navajo math circles. What we should have is make our own stories. And we're gonna do this one at the end. And for a while, I was thinking that instead of taking James's Annihilating Dots and Anti-Dots and Anti-Matter and so on, I said, let me create a new story where we have hunters and deer or something else. But I would like to actually learn from you and say, what is the better way of making the math problem which we have into something which your students can relate better to. Good, so let us discuss this one at the end of this story. So James has a really nice Australian accent. Yeah, I'm German, and he likes the story of, you have heard matter and antimatter. So you have protons and electrons and positrons and the universe after the Big Bang. So we have dots and we have anti-dots. And when they get close together, they annihilate each other, and there's kaboom in James's language. And I said, actually, let me stay with this one rather than putting deer and hunters together, or boys and girls or whatever, but I like to ask the last 10, 15 minutes, I'd like to hear stories from your side. Just say, we can make this problem a better story. So what we're gonna do is today, we're gonna put them on a circle, and I have a number of dots and anti-dots. And so now I have 5 anti-dots, I have 5 dots, I'll put another one in there. And what we're gonna do is, whenever one of the dots is close together, or an anti-dot, they're just gonna kaboom each other and they disappear. Kaboom. You like the story? So whenever we have a dot clockwise, no, counterclockwise. In math, we always go counterclockwise. If there's a dot getting close to an anti-dot, they just boom, go away from each other. Get the story? I can't see any of your faces. So once more, the story is, if they go in this direction, let's see what happens. I have 6 dots and 6 anti-dots in here. What will happen to them? And we're gonna get some math out of this one. Can you see something which is, let's put some clock in here so that's easier to read. So this one is 6 o'clock, this one is 9 o'clock, this one is 3 o'clock, 11, 10, 8, 7, 5, 4, 2, 1. Are there any ones which are annihilating each other? Tell me.
What?
11 and 9.
11 and 9, boom, they're gone. What else?
12 and 1?
Which one?
12 and 1?
4 and 1. No,
No,
they are not. They are
12
not next.
and 1. 12 and 1? Or wait.
Oh, 12 and 1. No,
Yeah.
It has to be in the order that the dot is
I
before
see.
the anti-dot.
Not the other way around. Okay.
3 and 1.
3 and 2?
3 and 2, boom, they're gone.
6 and 7.
6 and 7 are, we need a bigger piece of paper. Boom, they're gone. Which else? So again, it was in the order as the full dot and the empty one, always in this direction. Which other ones go away?
Do they have to be right next to each other?
Yeah, just whatever is left to each other.
5, 1. 5 and 8.
5 and
8.
no, 5.
1. 5 and 1.
Long way around.
6 and
Let's see.
11 and 8.
7 and 8.
yeah.
Which
11
one?
and 8. 11 and 8.
No, these ones are all gone. All that I have left is 5, 6, and 8, and we're always going around in counterclockwise manner.
Oh, counterclockwise now.
3, 11 and 8.
11 and 8. Yes, they are gone. And
5 and 1.
5 and 1, they are gone. And
That 5 and
1, agree?
1.
Yeah.
And there's one left over. How can that be? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. What happened? Teacher made a mistake.
There's no
I
7.
cheated. I cheated at some place. I don't know. It's the first time that I'm doing it with pieces of paper, and this one actually works pretty nicely. So I think they should all have gone away.
There
Agree?
was no 7, that's why.
Yeah, I did not write the numbers really nicely in here, but we have 6 anti-dots and 4 plus 2, 6 of these dots. Let's do it once more. Let's see if they really go away. So let's start. You tell me.
11
and
and
9.
9.
11 and 9, they definitely go away. And you watch that I don't make any mistakes.
Okay.
Now that 11 and 9 are gone, 12 is next to 8. Agree?
4 and 8.
So they can eat each other too.
3
And
and
then
2.
the only one which can eat each other are
3 and 2,
And 2.
3 and 2. And once they are gone,
5 and 1,
good. And then,
6
6 and
and 8.
yeah, so this one is 6 and the one on the top. And then we have the one on the bottom, goes all the way around. Agree?
7.
There's 6
This one
and 8.
goes all the way around, and
6 and 7.
this one goes away, and they all annihilate each other. Is it true that no matter how, in which order I put them, they will always go and pair up and go all away? So if I start with a different setup, I just got this really nice tool a while ago. So I put 5 of these ones in here. Would they always eat each other up? So whenever we have a dot and then an anti-dot, so a dot and an anti-dot, and if we have the same number of them, will they always eat each other until nothing is left if we have the same number?
Same number.
What is an argument so that they always eat each other? If we have full dots and we keep going around full dots, eventually they must switch. Agree? So if we have a whole bunch of these ones, let me put them this way. This one cannot eat this one. 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 But there must be one last one before we finally get to the empty circles. Agree? And whenever we have them neighboring each other, there must be, they can annihilate each other and kaboom, they're gone. Cool? So now this one doesn't have anything to eat. This one can eat the next one. Agree?
Yeah.
And once they are gone, this one actually will be able to start eating. And so at the very end, there will always be some food for the last of the black ones. Good? Now comes the fun part. Actually, let me do this one so that I don't have to draw this. So how many of these do we have? We have 2, 4, 6, 7, and 5. Let's actually have that we have 6 empty circles and we have 7 dots in here. Good.
6.
What I'd like you to do is draw this one on your own paper. So I'm starting here. This one is at 12. Doesn't have to be exactly in the same order. But what I have is I have 5 solid dots, no, 6 solid dots, then I have 3 empty circles, 1 solid dot, and 3 empty circles. Good. And let's see what will happen in there. If I have 7 solid circles and 7 solid disks and 6 empty circles, what should happen at the end? There should be something left over, agree? Because they are not the same number, so we expect that one of these ones will be left over. Can you tell me which of those ones will be left over?
The solid dots.
Yeah, which of the solid dots will be the one left over? Does it depend on the order in which they start eating each other? So we can have that this one starts eating this one, or this one starts eating that one. Agree? Which one is gonna be the one which is left over? Does it matter in which order they start eating? Could it be that this one is left over? It's a bad example. Should have done it slightly differently. Actually, yeah, let's do this one over here. So what's the first one which can eat something? The one on the bottom left can eat this one, agree?
Yes.
Yep, so these ones are gone. And then these two eat each other, agree?
Mhm.
And then what's happening next?
With the other side.
The 12 eats that one.
Everybody, I just wanted to quickly show some of the earrings that I posted yesterday that are for sale. So if you're interested, please direct message me and I can deliver to Tuba City or I can ship to you. But here is the first pair of before attending the IFW webinar, I was
Doreen, I think you don't need to be
making the right decision.
unmuted.
What I should be doing, but
Okay, good. So what's the next thing which happens? This dot eats this dot, agree?
Oh.
Yes.
And
Yeah,
then,
that one.
Yes,
Yeah.
and then this dot eats that
Good.
one,
Here.
yes.
Yes.
and then
That dot, the top dot eats
eats that
the,
one, and we have this one left over.
yeah.
Mhm.
Let's
Yes.
start with a new one, which is a little bit more interesting than the one which I just had. And you tell me in which order I should put them. And actually, let me start with the clock. That makes it a little bit easier. So we can talk about this one. 6, 12, 3, 9. So you tell me as I go around. I'm starting here at 3. Dot or anti-dot? You tell me.
That was the dots.
Dot. And then
And then
dot,
the dots.
anti-dot, dot, anti-dot, anti-dot, dot, dot,
Die.
anti-dot, dot. How many do we have? 2, 4, 6, and 4 of those ones. And I need one more so that the number doesn't eat each other up. Can you copy this one on your own paper? So I have solid, solid, empty, solid, empty, empty, solid, 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 empty, solid, empty, empty. Can you copy these ones?
Yes.
Yes.
So how many solid ones do we have?
Hold on.
I have 6.
7. I have 7 solid ones, and I have 6 empty ones. Good. So there should be 1 solid one be left over. Agree? But there's lots of choices who can eat whom. So whenever we have a solid one, we can get that these ones, kaboom, kaboom, eat each other. Good. So what I'd like you to do is you erase them. Everybody does it on their own, and you tell me which one is left over at the end. I hope that everybody gets a different answer. Do you expect that people get different answers? Which one will be left over? This one, or this one, or this one?
I got 9.
The
The
one
solid dots on
below
9.
the 9.
Mine is on the 9. The solid dot on the 9.
Is that the one which is left over?
That's what I got.
Somebody else got something else?
Mine is on the 8.
On the 8?
Yes.
Do you remember in which order you get them?
I got them.
Counterclockwise, isn't it?
It's counterclockwise.
Counterclockwise, right?
Mine is the 9.
Mine is
I thought
9.
before.
Me too. I got 9.
Yeah, mine is 9 as well.
Wow, that's quite amazing. Shouldn't be that if you do them in different order, then you get different answers. Okay, let's try it together then. Which ones are the first ones which go away?
12 and 11.
11.
Good,
2, 1.
good.
7:30,
3, 10.
Which one?
7:30 and 7.
Okay,
3, 10.
3 and 10,
6, 5.
6 and 5. And then
8 and 4.
yeah, 9 is the one which is left over.
Mhm.
Let's try it in a different order. Let's try it again. Just a different order. There's so many choices that we have. Let's start with these ones. 2 eats 1. What's next?
7:37.
Good.
12, 11.
2, which one?
12,
12 and
11.
11?
Oh, 12 and 11. Yep.
12.
Yeah.
6 and 5?
8 and
3,
4.
10.
3 and 10.
8 and 4.
8 and 4.
Again, it's number 9.
Yeah.
Why is it number 9 which is left over? Okay,
It is
Let's try.
followed by 2 solid dots.
2, which ones are?
It
Why
is
is
followed
not,
by 2 solid dots.
yeah, we have 2 solid dots here. Why is not number 2 or number 3 left over? It's always number 9 which is left over.
It's
I should have done this one before. Should not do these ones live. I should have a whole bunch of clocks ready. Okay, let's try another one. I take 6 of these ones. 3, 4, 5, 6, and 5 of these ones. Which one will be left over?
Hmm. 7, 9,
Any guesses?
7, 8. 5.
Which one do you think is going to be left over?
6. Oh, no, sorry. Hold on.
So we have 6 solid ones and 5 empty ones.
3,
3 is going to be the one left over.
I guess.
Why? Why? Okay, let's play the
Because-
game. So who eats whom?
It's solid.
2 and 1. Agree? That's one choice. 4 and 5.
11 and 9.
11 and 9,
11 and 9.
8 and 7,
12 and 6.
12 and 6.
Good. Great guess. Great guess. I think you know the pattern. So why is number 3 the one which is left over?
Hmm.
Let me do a very different way of, instead of covering them up, let me draw a different way. James didn't do that. It's a better way of doing this one. So instead of covering them up and removing them, I'm gonna connect them. So 8 eats 7. Agree?
Mhm. Yes.
That's a good one. 2 eats 1.
Mhm.
11 eats
9.
12 eats
6, 12, 6. 5, 6.
Agree? Let's do this one with the other pictures too, which we had a little while ago. So 6 eats which one? 6 eats
5.
5. 730 was 7. 8 eats 4.
Mhm.
Agree?
Yes. 12, 11.
Yeah.
Okay. There you go.
This one is left over.
Uh-huh.
Good. Have any of you been with me before when we did some Catalan numbers at a workshop?
Mm.
So this one is a very different topic, and I wanted to get this one in at the very end. Instead of eating and making them disappear, that's what James does. They disappear, these disappear, and so on. Agree? Do you see that this one is a very different way of representing the same mathematics? So the way we think of this one is non-crossing handshakes. So we play this one every once in a while at different math circles when we are trying to count how many different ways are there that people can shake hands. And what we have in here is we have the people standing around the table, standing around the circle. And what we like to do is shake hands with somebody else in the room. Good. And the rule is that you cannot shake hands or the arms cannot cross each other. So this one is not allowed.
Mm.
Agree? So this one is the picture for non-crossing handshakes. Or hands across the table. Good. So this one is just a different picture. Let us actually do this one with the other ones in here as well. So how did this one go? This one is a very different pattern. This one eats this one. This one eats that one. This one. This one. Where does this one go? It goes all the way here. This one goes here. And this one is left over. Cool. Does this one look somewhat similar to the web, which Amanda did with you a while ago? Good. So there's different ways of doing the same mathematics, but we are looking at this one in a different way. So things can disappear or they get connected, but the mathematics is the same of those. So why is this one the one which is left over? Why is this one the one which is left over? Why is this one the one left over? Let's try one more of these ones. You tell me, empty, full. I'm gonna start here. Somebody who's bold, not afraid of me. Empty or full, where we start? Just call them out, full, 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 empty, full, empty. Somebody who's not afraid.
Empty.
Yeah, empty. Just give me 11 in a row. Empty, what next?
Empty.
How about a solid?
Solid. Solid. Next. Empty.
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 Solid.
Oh, empty. Solid. 5, 6.
Solid. Okay, 7.
How many do we have? We have 7 solid ones and 6 empty ones. Which one is the one which is going to be left over at the end?
1.
What's your guess?
1, 2.
I guess a 6.
6?
6, yeah.
Okay, let's try. This one eats that one. This one eats that one.
I guess it's 7.
You think 7? Let's see. 5 eats this one. 1
6
eats
eats next.
10.
6 eats. Yes.
7 is left over. Agree?
Yes.
Good. So you have a pattern. You have a good idea which one is left over. Why is it this way?
There are more dots on the bottom.
Yeah, somehow it has something to do with that there's a whole bunch of them here. Agree?
Yes.
And then it should be the last one when we have a whole bunch of them together. Agree? But let's try it again. I have one more idea to get this one wrong. So I have a whole bunch of them here on the bottom. Two, 4, 5, 2, 4. That one is 6, and this one is 6. Let's see.
1 more.
2, 4, 5. 5, 6, 6. I want to have 6, 6, 6, 6, 6. Let me see. 2, 4, 5, 6. 2, 4, 6. And I need one more solid one. Which one is the one left over?
Ten.
10? But these ones are only 2 together. Here we have 4 together. Shouldn't this one be the one which is left leaving behind?
No.
So
No.
why is 10 the one which goes up? So these go away, these go away, these go away, these go away,
One.
Yep.
these go away, these go away. Yes, it is 10 o'clock. Good. So it is not, here we have 4 of them in a row. Agree? There's 4 of them in a row. And usually we think the last one of the biggest group is the one which is left. But it turns out that all of these 4 get something to eat, and it is the smaller group which is the one which is left over. Agree? Good. Let's come up with some idea with numbers, what is going on in this case. Let's do this one and say, every time we have a full dot, we add 1, and every time we have an empty one, we subtract 1. So I start with some dot somewhere. So I say this one is 0. Then this one is, if we are going in this direction, what we get is
+1.
yeah, so this one is 1. This one is
+1.
+1 is 2. Then we,
Subtract.
so this one is then
1.
1. This one is
0.
0.
This one is
-1.
Negative 1.
-1. Oh, I'm screwing this one up. Then we go back up to
Negative
0.
2. Oh, 0.
Good. Then we go to -1, -2, -1, 0, -1, and this one is, oh, I screwed this one up. I shouldn't have done this one. Let me.
Would you start at 1?
Yeah,
Okay.
I made the mistake. I shouldn't have started here on the bottom. To make it more interesting, let's go back to one of our previous examples. Oh my God, good pictures. Oh, yeah. Let's start with the one which is left over. So this one is +1 and empty is -1. And this one is the one which is left over. Agree? So let's
Yes.
start at this one, and this one is our 0. Then we get to, this one is our, we're going in this direction clockwise, as we always do in mathematics. We go against the clock when we measure angle. So we are going 1, then we go up 1 more. Agree?
+1. Yes.
2,
3.
3,
2.
1,
1. 0.
0.
1. 2. 1.
0.
0.
Then 1.
1. 0.
0.
Good. So the numbers are all positive in this case. Agree? No negative numbers. Good. So there's no negative numbers if we're starting with the one which is left over. Does that make sense? So that means that on the one which is left over is the 0, and each of these ones gets something to eat, and we can express this one in terms of numbers. Cool. Let's do it in a different way. I start at 0, I go up 1, I go up 2, I go up to 3, so 0, 1, 2, 3. Then we are going down to 2, going down to 1, going down to 0, up to 1, up to 2, down to 1, down to 0, up to 1, down to 0. Yeah. So this one is a different picture for this one up here. So I call this one a mountain range. And this one is the one which is left over. And what happens in the mountain range, it never dips below 0. Agree? Let's try it on one of the other ones in here. This was the previous one. So the 9 was left over. Let's get some fat marker in here. So if we start with 0 in here, what are the numbers which we get? It is black is 1, then 2, then it goes down to 1. So it is 0, 1, 2, 0, 1, 2, down to 1, up to 2 again, down to 1, down to 0, up to 1, up to 1, up to 2, down to 0, down to 1, up to 2, down, down. 1, 2, 1, 0. Agree? This one is the mountain range which we get. Yeah. Is there always a way that we can start in such a way? So I started here with the wrong number in here, remember, where we got negative numbers around here. This one was a bad start. That's not the one which is left over. The one which was left over in this particular example was this one over here. Agree? But if we're starting with the one which is left over, then we always get something which always stays above 0. Good. So in which way are they eating each other? The up and the down arrow, when they are right next to each other, they just disappear. The up and the down, they disappear. The up and the down disappear. The up and the down disappear. Up and down disappear. Up and down disappear. This one is left over. Do you like this picture?
Yeah.
This
Nice.
one is the same mathematics as what we did with hands across the table, or where we actually have things which annihilate each other. I'm personally a great friend of saying it is the same kind of mathematics, but it is different symbols. We look at it in a very different way. Yeah. So there's always one which is going to be left over. We know that this one is the black one, and it is characterized by, if we start at this place, then we are always having a mountain range which only goes, stays above the 0 line. Yeah. And as I said, this one is a different class, a different session. where we are counting all possible mountain ranges or all possible rearrangements, and they turn out to be phrased with Catalan numbers. And I hope I see you at some other time where we are doing an exercise with counting those ones. But now I have a different story in here. This one is if we start with a circle, but we have an even number in there. So as I said, we have, say, 4 of these ones. So we have 4 solid ones and 4 empty ones. Okay, so these ones are the same. There's nothing left over. And you are coming from the outside. And your question is, where is a safe place to join the circle? Where would you go so that you are safe, that you don't get eaten? Or that, yeah, that you're not annihilated by one of the empty circles? Where would you go?
Nine?
Above or below? So
Above.
I already have somebody at 9. Would you go above 9 or below 9?
Below.
Below, agree? If I was above 9, then I would get annihilated by 9, agree? What's happening in this case? This one eats that one.
Below 8.
This one eats this one. This one eats that one. And what's left over? We have 2 solid ones and 1 empty one. Agree? Who eats whom? Agree? So this one is a safe spot to enter. Let's do it again. I'm gonna take a small circle now. I'm gonna go faster. Is there always a safe spot? Is there always a safe spot? So we have an equal number of solid ones and empty ones. And we know that if we leave them alone, they will always disappear. Agree? They will always annihilate each other. If we have one extra one, then there will be one black one left over. Agree? There will always be one black one left over. And if we're smart enough, we should be able to decide where that black one goes so that it is safe. Where would you put this one? Where would you go if, in this case? If I go down here, I have to eat this one. They go away. If I go
Below
here,
1.
if I'm going here, is that safe?
Yes.
Is this one safe?
Yes.
No, that one will eat this one. Agree?
Oh, yeah.
And is this one safe?
I think no.
Yeah. So what we have is we have more than one position which is safe. Agree? So is there always a safe spot? Yes. Why? Because if we know that these ones are the same number as these ones plus 1, there is one black one will be left over. And we know how to find that spot. Such safe spot. Good, but it can be, there may be more than one. The next story, which is nice, is, let me draw a nice circle again. If we have something like, let's say we have 2 solid ones and 2 empty ones, how many different arrangements? Of the 4 dots are there? How many different ways could we arrange these? We have a solid one. After the solid one, what could we have?
Be the empty.
Yeah. We could have an empty one.
Uh-huh.
And
Yes.
then?
2. Might be empty.
Empty. And then there's one solid one left over.
Yes.
Agree? So I have solid, solid, empty, empty. Are there other possibilities to arrange them? Solid, empty, or solid, solid, empty, empty. Is this one all possibilities?
Yes.
Good. Let's think of these ones again as mountain ranges. This one is up, up, down, down. Agree? Up, up, down, down. And in this case, what we have is up, down, up, down. Agree? Okay. So in this case, I have an equal number. So I get back to the place where I started with. And is there any other way of arranging them in a possible way?
You mean like number line or something?
Yeah, I mean, is there any other way? Solid, solid, empty, empty, or solid, empty, solid, empty? Is there any other way of arranging them?
Oh, I see.
I could have started with empty and then make it solid, and then empty and then make it solid. But this one really is not a different pattern because this one is just rotated. Agree? It's kind of just rotated. So I think that this one is pretty much the same pattern as the black one. Next one. Let's think of, I have 3 solid ones and I have 3 empty ones. Oh, let's do it a different way. 3 of them going up and 3 of them going down. Yeah. How many different mountain ranges can I have? We can have
3.
up,
3.
Mhm.
up, down, down,
1.
down. Agree?
Oh, yeah.
Give me a different pattern.
Oh,
I could go up, down, up, down, up, down. Agree?
yes.
So this was U, 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 D, D, D. This one
Yeah.
is
Yeah, that's
U.
how I was thinking of that. There you go. Yeah.
Good.
Mhm.
What else? I'm not allowed to go below the line on the bottom. We're having mountain ranges, no uranium mines. Give me another arrangement. Up, up, down.
Down, down, and then up, up. I'm sorry. Down,
Yeah.
up, down. There you go.
U, U, D, D, U, D. Agree? Can we switch the order of these two?
Yes.
So this one is up, down, up, down, down. Is this one all possibilities or did we miss one?
Mm.
Up, down,
Down, up,
down. We already have that. Up, down. We could continue with
down, down. Then up.
up, down, down. We already did, but we could go up again. Agree? And then down, down. So this one is up, down, up, down, down. Agree? Let me do something really wild and silly. And we're going in the direction of Catalan lecture. I'm gonna change the symbols. I'm gonna make them this way, that way, that way. So I'm using parentheses. So when you're teaching algebra, you have 3 plus 4 times 5 plus 2 times 5. Agree? So you have expressions with parentheses. You always do multiplication first and then addition after. Agree? And what you have to have is the number of open parentheses has to be always larger than the one which is close parenthesis. Agree? So this one is open, open, close, open, close, close. This one is
Open.
open, closed, open, closed, open, closed.
Open.
This one is open, open, closed, closed, open, closed. Agree? Open, closed, open, open, closed, closed, open, 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 closed, closed, closed. Cool. And what we can do with all of these ones is we can also think of them as our things on the circle. So if I think that these ones are the solid dots, and we have 3 solid dots followed by 3 empty dots. Agree?
Yes.
And we get this picture in here. Cool.
Mm-hmm.
And if I take this mountain range here, up here, what do I get? I get solid, solid, open, solid, open, open. Agree? And since it's an even number, nothing will be left over, but this one eats this one, this eats this one, and this one then eats this one over here.
Mhm.
Good. So we get really cool patterns in there. David, how long do we have?
Let me take a look here. I think it's supposed to be roughly 90 minutes. And so does that mean that you have an extra 15 minutes?
Oh, that long? That long? Wow. Actually, I'm running out of space in here. So there is one more story also from Dave and from James. And what we're gonna do is we wanna put, instead of numbers +1 and -1, what we're gonna put up is, yeah, I had a picture of, oh, it's gone, too bad. So what I wanted to have is a map of the nation. And we have towns and we have highways and gas stations. But I'm gonna start with James's story, and he basically thinks always of Australia. And I just couldn't come up with a real nice story to put it into the terms where we go from Kayenta to Tuba City to Window Rock to Tsaili and so on. But I think we will do this one at the very end. So let's think of this one as being Australia. And what we're gonna do is we have a rent, we have truck, and what we wanna do is drive all the way around, all the way around. And what we're gonna put in is we put some gas stations. Actually, let's think of these ones as barrels of gasoline. Gasoline, actually it is diesel, it's better. We're talking trucks. Trucks eat diesel, that's much better. And so we're gonna drive around and we have a number of barrels in different places and they hold different amounts of gasoline. So let's say we have 40 here, we have 20 here, we have 30, 30, and 20 here. And when we go from one, so this one is a total of how much? 40, we can change them in any order. 30 and 30 is 60, and 40 is 100. So this one is a total of 140 gallons. Agree? And as we travel around, we need a certain amount. So let's say this one is 30, this one is 40, this one is 20, this one is 30, 40, 20, this one is 50, 30, 40, once more, 30, 40. The numbers don't add up correctly. Let's make this one 10 and 10. So where should you start driving so that you don't run out of gasoline?
140.
what happens if we start here? We start with 40. Good. What happens next? We drive all the way around the top corner of Australia. And before we get to the next barrel, we are going down 40 and we are burning up 30 gallons of diesel. Agree? So how much is left at the end?
10.
We're going down to 10. And we find that there's a barrel of 20 left. So we are going back up to, so this one is plus 40, minus 30, plus 20. So we are now at 30. Good, so we are now at 30. And before we get to the next barrel, what happens?
Negative 10.
Negative 10, dang. That does not work with my truck. My truck does not hold negative numbers of gas of diesel. Agree? Bad choice. Good, so we are in trouble in here. So this one is a bad starting point. Where should we start? Is there always a place where we can start so that we do not run out of diesel?
30 at 9 o'clock.
If we start with 30, so we go up from 0 to 30, then we are going 10 down to 20. Agree? Then we are going up to
50 to 20.
So we are done with minus 10. Then we get plus 30. So we are going up to 50. Agree?
Yes.
And then down to 40.
Mhm.
Wow, we're going all the way up to 90. Then down to 50. No, sorry. All the way up to, I said this one the wrong way. No, this one is nonsense. So 50 to 40.
Okay.
But now we need 50 gallons, so we are getting down to minus 10. We are in trouble again. Let's see, did I set this problem up in the wrong way? The total that we need is 40, 10 is 50, 100, 140. So we have 140 down and we have 140 up. And if we start it in here, 30, 20, 50, 30, 30, 20, 50, 40, minus 10, we are in trouble again. So this one is a bad start too. Agree?
Wait. 30, 20, 50.
30. Did I say this one wrong? Let me try it again. What is happening? Once more. We start with 30 up. Good. Then we go 10 down.
Yeah.
And we are at 20. Agree?
Yes.
Now we're going 30 up. So we are at 50.
50. Yeah.
And then
10 down.
10 down. So we are at 40.
Mhm.
Once we're at 40, we can fill up 20 more.
Mhm.
And we
60.
get to 60.
Yes.
Agree? And then we have this big hole where we are going 50 down, but we are still good at 10.
10.
And then we get 40 up, so we get up to 50.
50.
And then 30 down,
20.
so we are at 20. But at 20, we get 20 up.
Mhm. 40.
40, and we get 40 down to the end. And we say, wow, we made it all the way around. Good. So it was right. This one was the good choice. Is there always a way to find a place where you should start your journey? So we are driving all the way around from Kayenta to Window Rock, to Tuba City, to Tseli, to Chinle, to Shiprock, to Crown Point. Is there always a way that we will never run out of gas if we have so much gasoline at the right place? So if we have something where we have a mountain road which goes below 0, what should we do?
Change your direction.
Yeah, we should change our starting point. Agree? Where would you start this travel? What I'm gonna do is I'm gonna start my travel here. So if I start my travel at the lowest point in there, but so if I started here, I run out of gasoline at some time. Okay? So the better way is to start at this point and then put my mountain range to this side in here, and I always stay above the ground. Does that make sense? Good. So is this one related to the dots on the circle? It is. Solid, 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 empty, solid, empty, solid, empty, empty, empty. And then the story which we asked earlier is this one a safe place to start? Where is the safe place to be, that we never run into negative territory? So the key part is whenever we have a word like this one in here, so it is up, down, up, down, 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 up, 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 down. What we do is we change this word, so this one in here, and we have a safe place to go. You like that? So these ones are very, very simple games. I'm doing this one in my own research. It's very important that I have some rearrangements which are always in such a legal way, and I can think of it as gasoline and diesel. I can think of them as dots on the circle. I have mountain ranges, I have parentheses, and they are all the same mathematics. Good. And we played 2 games in here. So one of our games was the one where we are going around Australia, and the number of ups is the same as the number of downs, but there's always one smart place where we can start the travel so that we never run out of gasoline, or we never go empty in the right way. Now I want to hear from you. I'm gonna stop sharing my screen, and I want you to tell me different stories. So instead of what James had. So James had, actually I share my screen still for a moment. So we have dots and anti-dots. And this one is kind of cool if you're doing modern physics, and it is matter and antimatter. But I want to have better stories for them. And what I'd like you to do is give me some idea that which is native to your area where you just say, I can make a story with different kinds of things. I don't need them to annihilate each other. Annihilate. I don't like this one. I want to come up with better stories. So my first idea is I have hunters and I have deer. The only problem with this one is they are harder to draw. And then I have a hunter in here. And then I have a hunter in here. Who gets which one? This hunter gets this deer, and this hunter gets that deer. Can you give me different stories?
A Navajo and a sheep.
Navajo and sheep. I like that a lot better. So Navajo and sheep. So this one means you are at a farmer's market. Or at a fair. Good. And we have so many sheep, 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 person, person, sheep. Good. And everybody gets to take home a sheep for the holidays. Agree? So this one gets, this sheep goes to this one, this sheep goes to that one, this sheep goes to that one. Agree? Give me more stories.
Mm.